Good morning, everyone. I am Mrs. Dolly Jain from Lovely Public Senior Secondary School. Today, I am going to teach topic work from chapter Work and Energy from class 9 Science. Let us understand the topic from its definition. For work to be done, a force must be exerted and there must be motion or displacement in the direction of the force. The work done by the force acting on the object is always equal to the magnitude of the force multiplied by the distance moved in the direction of the force. Work is a scalar quantity, children. It has only magnitude but no direction. The formula we use for the work is force into displacement. W is equal to F into S. F is force applied, S is the displacement of the object, and W is the work done. Work is different from working hard. Work in terms of physics needs two conditions, children. A force should be acting on the object and the object must be displaced. Work is defined as the product of force and displacement in the direction of force, as you can see in the figure. Work is equal to force into displacement. Its SI unit is joule. As you all know, force is measured in newtons and displacement in meters. So work has a unit 1 Newton meter, which is equals to 1 joules. Now, how do we define 1 joule? It is when 1 Newton of force displaces an object through 1 meter in the direction of the force, then the amount of work done is, children, 1 joule. 1 joule is equals to 1 Newton into 1 meter. Children, let's explore the three types of work. It is positive work, negative work, and zero work, along with the real life examples for each. Positive work. If force and displacement, or the force and the components of displacement, are acting along the same direction, then, children, the work done is positive. Angle between force and displacement is acute, therefore work done is positive. So many examples we can come across in our daily life. You can see in the figure, children, when a man pulls a cart or a horse pulls a cart, force and components of displacement are acting along same direction. Thus, here the work is positive. What about pushing, children? Work done during pushing is negative or positive? As displacement and components of force is along the same direction, work is again positive in this case. When force is applied to lift up any object, force and displacement are acting in the same direction. You can see the children in the figure. When a body falls freely under gravitational pull, the work done by the gravity is positive. Now, let us do negative work. Let us understand what is it. When force and displacement or the components of displacement are acting along opposite directions, then the work done is negative. Angle between force and displacement is obtuse. Therefore, work done is negative. Let us understand through the example. Yes, children, when a body is allowed to slide over a rough surface, the work done by the frictional force, which is not the applied force, is always negative. When a south-north pole repels south-north pole of another magnet, they move away from each other, as you can see in the figure. The work done by the magnetic force between them is negative. Children, when a body is thrown up against gravitational pull, then also the work done by the gravity is negative. I hope the negative work done is clear to you. The third type of work, children, is zero work. When no force is applied, for example, you are drawing a diagram, you are organizing your thoughts, you are collecting question papers, or you are doing meditation, then you are not doing any work. Work done is zero when displacement is zero. That is W, that is work done is zero when displacement is zero. That is, if you are pushing a huge rock or a wall, then in that case, no work is done if the force you are exerting does not make the object to move. Moon when completes one revolution around the earth, then also displacement is zero. So in that case also, children, the work done is zero. Man standing with a load on his head or holding a briefcase, you can see in the figure, and waiting for the bus also has a zero work done. When theta is 90 degree, that is the angle between, children, the force and displacement is 90 degree, the force is perpendicular to the distance. Or even when the force and displacement are there, but still the work done is zero because they are perpendicular to each other. Also, children, another example, a man carrying a suitcase and a walking, or a coolie carrying luggage and walking, all are the examples of zero work done. Now, let us understand the concept of the work through a numerical. A force of 10 Newton causes a displacement of 1 meter in a body in the direction of the force. Calculate the work done by the force. We all know that work done is equals to force into displacement. When a force of 10 Newton is acting on the object and displacement is 1 meters, so the work done will be 10 joules. Children, you must have understood the topic very well. I hope so. Thank you very much.